at one more example, maybe a little bit more complicated than what we've done before. We're going to use a slightly different substitution. So cosine is not going to be exactly r cosine theta, rather x is not going to be exactly r cosine theta, and you'll see why. So I have an integration in terms of x and y. It's integration 0 to 2, integration 0 to square root of 2x minus x squared, x times y, dy, dx. So I want to try to figure out what the heck that looks like in my xy plane. My bounds for y are between 0 and this square root, so I'm going to set y equal to the square root. Because this is the section on polar coordinates, and because I've got this square root thing and the x squared going on, I'm thinking this probably is the equation of a circle, a semicircle, or something like that. I want to see if I can write it in that form. I know that the equation of a circle is x minus, I'm not sure exactly what letter is typically used, but x minus some constant squared plus y minus some constant squared is equal to the radius squared. That's the equation for a circle. So let's see if we can find something like that here. In order to do that, I'll need to complete the square. So let's think about the right-hand side here. I have y squared equals 2x minus x squared. If I complete the square, I'll start by writing it as minus x squared minus 2x. So it looks like if I divide negative 2 by 2, I get negative 1. Square that, I get 1. So I'm going to add 1 inside the parentheses. And that's actually subtracting 1 because of the negative. So I'm also going to add 1 outside of the parentheses. So I subtracted 1 and I added 1, which is no change. So I get to say this is y squared equal to minus of x minus 1 whole squared plus 1. So if I move this guy over, I see I have y squared plus x minus 1 whole squared. And that's equal to 1. So I have the equation for the circle that I was looking for. The number 1 here, and the fact that there's nothing in the parentheses with y, that gives me the center of my circle. So this is a circle centered at the x-coordinate 1, the y-coordinate 0, and the radius is the square root of 1, which is 1. Okay, so I found out that this is what y is running between. So let's try to draw a picture. Circle centered at 1, 0 of radius 1. Something like that. So I'm told that here my y is running from 0 to that, and my x is running from 0 to 2. So it looks like this is my region of integration. And I want to know how I can express that in polar coordinates. So I have the upper half of a circle, and I know that when I have the upper half of a circle, my theta is 0 here. And as I'm moving around the circle, I get to eventually theta is equal to pi. So it looks like I want my theta between 0 and pi. But what I have to take into account is this shift. The fact that this domain is no longer centered at the origin, it's shifted a little bit, means I have to make a change in my substitution. Instead of x equals r cosine theta, I'm going to say x minus 1 is r cosine theta. So the x minus 1 coming from here, and I'm going to say y is r sine theta. So x is equal to r cosine theta plus 1 by my substitution. Now I'm ready to set up my integral. I am going to use 0 to pi for theta. And I am going to use the fact that it's a circle of radius 1, 0 to 1, for my radius. And the only thing that's going to change is when I integrate the function x times y. Now my x is r cosine theta plus 1. My y is r sine theta. I get r from my Jacobian, and I'm integrating with respect to r and then with respect to theta. So I just have to do a little bit more algebra. I'm going to distribute this. So I get r cosine theta times r sine theta times r. So that's r cubed sine theta cosine theta. And then I have plus 1 times r sine theta times r. So plus r squared sine theta. And that's what I'm integrating dr d theta. So I'm going to split this up. I know that this first one, I'm going to do the u substitution. I'm going to say u is equal to sine theta, so du is cosine theta d theta, and if I change my bounds between r and u, if r is 0, I'm sorry, between theta and u, so if theta is 0, then I'm going to get zero, and if theta is pi, then I'm going to get 0. So I actually wanted to do this a little later. So I forgot to integrate with respect to r first, but that is going to come. So how about this? First we get r to the 4th over 4 sine theta cosine theta, and r cubed over 3 sine theta. Now we're ready to do that part. Evaluate between 0 and 1. So I get integration 0 to 1, 1/4 sine theta cosine theta. I'm sorry, integration 0 to pi. 1/4 sine theta cosine theta plus 1/3 sine theta d theta. And here's where I'm going to make the substitution that I was describing. So I let u equal to sine theta du cosine theta d theta. If I change my bounds between theta and u, and this of course is just taking care of this much. Theta was 0, I plug in sine of 0 is 0. So if it's 0, I get sine of 0 equals 0. And if it's pi, sine of pi is 0. So this much is integration 0 to 0, 1/4 u du And this one I'm not going to change. I'm going to keep this as integration 0 to pi, 1/3 sine theta d theta. And so you can see here that integration 0 to 0 is 0. So I don't even worry about that anymore. Antiderivative of sine is minus cosine. And I'll be evaluating at 0 and pi. Cosine of pi is -1, so this is -1/3 times -1 minus -1/3, and the cosine of 0 is 1. So it's 1/3 plus 1/3, 2/3. So 2/3 is the value of the integral. I'm going to look back up and see the instructions for the problem. Once you've written your answer as a fraction, find the fraction, find a plus b. So I'm going to say if a is equal to 2 and b is equal to 3, then a plus b is 5. And I can answer the question that way.